Test. All right. Good morning, everybody. So today we're going to go over the practice test number 3, the one you took as your final. This is the no calculator portion. So all of you should have gotten a copy of the solutions, the written out solutions, and I'm going to just go over a few problems that I found we scored pretty low on. So starting with number 3. Number 3 says, which of the following is equal to a to the 2/3 for all values? Okay, so you can see I even titled some of these. This one's exponent rules. A to the 2/3. So now a to the 2/3, one of the rules we have is that a to the 2/3 is whenever I have a fraction as an exponent, that always means it's a radical. The 3 being the root always goes at the bottom, and the 2 being already an exponent on top stays on top, and the a goes right there, okay? So a to the 2/3 can also equivalently be rewritten as cube root of a to the second. Now, just in case this shows up, in the event I have a to the negative 2/3, I can rewrite that as the cube root of a to the second, but it simply just goes in the bottom of a fraction, okay? Reminder, negative exponents mean it goes, take the reciprocal, put it on the bottom of the fraction. Okay, and that's why you can see that the answer here is just D. Okay, the next question I'd like to go over with you guys is number 8. So it says the line y equals kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains the point CD, where C and D are not 0, so neither of those are 0, then what is the slope of the line in terms of C and D? So remember, so here's one way of doing it. You can use the equation of y equals mx plus b and help yourself solve. Here's another way that I found helps some students. I have y equals kx plus 4. So since you have y equals kx plus 4, I can actually graph this, and I don't have to be perfect about this, but I can sketch it. Now, y equals kx plus 4. You do know one thing about this graph, and that's the starting point. The starting point has to be 4 units up, okay? Now, you don't know anything else about this graph, okay? But you do know one thing. It has to go through some random point C comma D. So I'm just going to graph some random point C comma D, and I'm going to draw a line that goes through it, okay? So as far as that goes, the question then comes down to, what is the slope? Well, the slope is really just the k value, right? Well, I know there's a formula for slope. Again, this is one of those formulas you definitely need to know. Formula for slope is y2 minus y1 over x2 minus x1. If we're going to have to know some formulas, this is one of those formulas you definitely want to know. And what you can do from there is you can say, okay, how much do I have to go up and how much do I have to go over to get there? Or if this is 0, comma 4, and that's C, comma D, I can use the formula and say, okay, I have D, the y2 value, minus y1 over x2 minus x1, and this simplifies to our answer, D minus 4 over C. So you can see how I also get that. If I didn't feel comfortable using the equations, I could absolutely use the graphs here. Okay. The next problem I want to go over is number 9. I have this system of equations. So I'm just going to first copy down the system of equations. Kx minus 3y equals 4. Kx minus 3y equals 4. And 4x minus 5y equals 7. 4x minus 5y equals 7. Okay, so now what is the question? In the system of equations above, k is a constant, and x and y are variables. For what value of k will the system of equations have no solution? Okay, so no solution means something's wrong, something doesn't add up, okay? But if I know I have a system of equations and these are two lines, the only time two lines never cross is if they are parallel, right? And that's what the key is behind this no solution. It means it's code for parallel lines. Well, I have to remember one thing. Parallel lines have the same slope. At the very minimum, they have the same slope. They may have different y-intercepts, but they do have the same slope. So if I look at this equation, you can see I already have something going on that's weird because I have three variables, but there are only two equations. So what I can do is I can actually just try to find out, okay, I know I have the same slope. Maybe if I solve for y and compare them, it'll help me find out what k is. Because if I solve for y, at least it kind of eliminates a variable. So I'm going to take the blue one and I'm going to solve for y there. So that means I have to subtract kx. So subtract kx from both sides. So negative 3y equals negative kx plus 4. And then I'm going to divide everything by negative 3. And that gives me y equals k over 3 x minus 4 over 3. So I know the slope of this one is k over 3. If I do the exact same thing with the red one, subtract 4x, subtract 4x. So then I get negative 5y equals negative 4x plus 7. And then divide all three sides by negative 5. I get y is equal to positive 4 over 5, because two negatives divided by each other give me a positive, minus 7 over 5. And then the slope of this one is 4 over 5. Now, if I already knew that they had the same slope, I can now set these two things equal to each other. 4 over 5 equals k over 3. Now I'm only down to that one variable. So how do I solve this? I can cross multiply. 4 times 3 is 12. 5 times k is 5k. And k equals 12 over 5. And it's either that as a fraction, or if I had to have the decimal, but this is the no calculator section, a reminder, to divide by 5 without a calculator, you take the top number, double it. So I'm going to take the top number, I'm going to double it, so that's 24, but then move the decimal place over, so 2.4 or 12 over 5, whichever one I get. Well, if I look at the answers, 12 over 5 is the correct answer. Okay. Number 11. I'm going to remain on this picture right here. So let's go through the work. So in the figure above, lines K, L, and M intersect at a point. If x plus y equals u plus w, which of the following must be true? So if these are all lines forming, so M extends all the way across, K extends all the way across, L extends all the way across. That means angles such as y and u have to be the same. Okay, but rather than making a big mess out of things, what I'm going to do is I'm going to say this is a triangle and this is a triangle. Okay, and therefore z must compare with w, and x is congruent to t. The reason I do that is because when I have this equation like this and I'm mixing algebra with geometry, I don't want to use those little arc symbols. So x plus y, if I write that out, square plus y, which is triangle, is equal to u plus w, triangle plus w is a circle. What I can see is, oh, I have triangle on both sides, so I can cancel that out. And squares and circles are the same, so that means this is actually equal to a square, and so is this. So that actually means, guess what? Y and u are the same, but also x and w and z and t are the same. So if I go through this, I can see, yes, x and z are the same because they're both the same shape. Y and w are not. Y is a triangle, w is a square or circle. Nope. And does z equal t? Yes, both of those are squares. So those are also congruent. So that's why the correct answer is 1 and 2. Okay. Number 12. So I have y, which is equal to ax minus 2 times x plus 4. In the quadratic equation above, a is a non-zero constant. The graph of the equation in the xy plane is a parabola with the vertex c comma d. Okay, vertex is always the highest or the lowest point of a parabola. Which of the following is equal to d? So one of the ways you can do this, and this is the work I just showed that's currently on the screen, is what happens if I distribute everything, but then rewrite it using completing the square. If I do that, I can actually see that I have negative 9a. Now, since that's not always the most intuitive way, an alternative, or one alternative at least, is I can actually see that I have x minus 2 and x plus 4, and I can set those equal to 0 because it's already factored. What does that mean on the graph? Just so we can get an idea of what that looks like on a graph. If I have y is equal to a times x minus 2 times x plus 4, well, what I do know is that if I plugged in positive 2, that'll give me a point of 0 on the parabola. If I plug in x equals 2, I get this point. Now, if I think about this, what other values will give me a whole thing to equal 0? What value can I plug into x plus 4 that would give me 0? That would be negative 4. Okay? Which tells me that the middle of this graph is right here at negative 1. And that's what this is saying. The x-coordinate of the vertex, the middle, is negative 1. Well, since I know that the x-coordinate is negative 1, if I want to find the y-coordinate, because that's what I want to find, what is the value of d, the y-coordinate of the vertex? All I have to do is plug negative 1 into this equation up here. What does that give me? Y equals a negative 1 minus 2 times negative 1 plus 4, a times negative 3 times positive 3, which equals negative 9. I'm sorry, negative 9a. Okay? And that's why the answer is A. Next question I would like to go over with you guys is number 13. So it says the equation 24, that whole thing, I'm not going to read it off, is true for all values where a is some constant. What is the value of a? Okay, now understand the language. If this is saying this equation is true for all values, so no matter what x is, or no matter what I can plug in for x, the left side and the right side of the equation are always going to be the same. So then the question is, okay, if the left side and the right side are always the same for all values of x, then what's the value of a? So one way is what I showed right here, which is kind of like getting common denominators. So I'll show that again. 24x squared plus 25x minus 47 over ax minus 2 is equal to negative 8x minus 3 minus 53 over ax minus 2. And one thing that I work on is how do you solve equations that are very, very ugly and complicated like this? Well, what I'm going to do is I'm going to multiply everything by ax minus 2. And the reason I do that is because it's going to actually cancel out all of the denominators, okay? So if I multiply x minus 2 times the first one, this one, I'm going to be left with just the numerator because the x minus 2 is going to cancel. So then I'm left with 24x squared plus 25x minus 47. Now, if I multiply ax minus 2 times negative 8x, well, that's going to make things a little bit more complicated, but it's worth it. So I'm going to write it like this for a second. I'm going to multiply ax minus 2 times negative 3, ax minus 2. And I'm going to multiply ax minus 2 times the last one, but then the denominator again cancels, so it's just minus 53. Okay, so if I distribute everything that I just had, let's see what I get. 24x squared plus 25x minus 47 is equal to negative 8ax squared plus 16x minus 3ax plus 6 minus 53. Now what you can see is if the left side and the right side, like I said, are supposed to be the same always, then whatever number is in front of x squared here should be the same as the number in front of x squared here. Well, since I have 24 should be equal to negative 8a, it's a quick way of solving for a. 24 equals negative 8a, so that means divide by negative 8. A is equal to negative 3. Okay? Now, an alternative way of solving this, just for comparison's sake, is, like I said earlier, this should work for all values of x. So let's think about a number of, for x, we can plug in that would make this equation very, very easy to work with. Well, you can't plug in 0 because that makes all the a's go away also. If I try plugging in a equals 0, or sorry, x equals 0, all the a's go away. Not going to be helpful. So instead, I can also plug in x equals 1. If I plug in x equals 1, because this is supposed to work for all values of x, just like it said, then I get 24 plus 25 minus 47 over a minus 2 is equal to negative 8 minus 3 minus 53 over a minus 2. If I clean this up a little bit, I get 24 plus 25 is 49 minus, so that's 2 over a minus 2 is equal to negative 11 minus 53 over a minus 2. I do the same thing, but now I only have to multiply by a minus 2, which gives me 2 equals negative 11, a minus 2 minus 53. And to save time, I promise you when you solve this, a is equal to negative 3, just like before. Okay? I quickly wanted to reference number 14. The reason I wanted to reference number 14 is because it asks for what are the solutions to this equation. Please make sure you remember the quadratic formula, okay? Quadratic formula is a very, very helpful equation for the SAT, okay? Just like the slope formula for number, I think it was 6, the quadratic formula. Take the time to memorize. You can see I had to work through this quadratic. And again, when do I use quadratic formula? When I have x squared. I was able to figure out that the answer is negative 2 plus or minus 1 root 2, therefore 14. It becomes a lot easier if you knew that formula. All right. And I believe that is it for this page. If you have any other questions from the no calc portion, I attached another video. It's not my video, but it's made by someone that did a really good job going over every single one of the questions from the no calc portion. Feel free to review that. Good luck on Wednesday.